Okay, well, thank you very much for inviting me. So this paper is called Income Differences and Input-Output Structure, and it's joint work with Christian Chilino, who's at Essex, and Maria Tetriatnikova in Vienna. So this is a very much of a macro paper and deals with a very grand questions. And of course, we never have the satisfying answers to the grand questions. So the question we're trying to deal with in this paper is to what extent input-output structure can help us to understand differences in income per capita across countries. The standard approach to that in a macro is basically to posit an aggregate production function for value added. So basically, aggregate GDP is maybe a Cobb-Douglas production function, uses capital and labor as inputs, and lambda is aggregate productivity of the country. And if you have data on capital stocks per capita and income per capita in purchasing power parities, you can basically back out the productivity that makes this relationship fit perfectly. But of course, in reality, the production structure of countries is much more complicated than that. We've been talking about this for 2 days now almost. In reality, basically, GDP aggregates value of many economic activities which are basically connected to each other through input-output linkages. So, for example, if you consider a productivity change in the transport sector, that will affect all the sectors that the transport sector delivers to. For example, mining uses transport as an input, and therefore a productivity increase in transport will basically reduce the price of this input and therefore lead to an increase in output of the mining sector. That will have repercussions on the steel sector, which uses mining as an input, which will also experience an output increase. Steel is an input for transport equipment, which in turn is an input for the transport sector. So this is going to have a second round effects and higher order effects as well. And the total effect of the productivity increase in a given sector is what we call the input-output multiplier of that sector. So the I/O multiplier of a given sector basically summarizes all these intermediate effects, and it tells us by how much aggregate income or aggregate value added will change if productivity in that sector changes by 1%. And of course, sectors are very different in terms of the size of their multipliers. So sectors that have large multipliers are, for example, basic infrastructure sectors, such as transport or energy, that basically is supplied to a large number of sectors in the economy and is used relatively intensively as an input by other sectors. So basically, the multiplier depends both on the number of sectors to which a given sector delivers and the intensity with which it is used as an input. And that, of course, implies that low productivity levels in different sectors will have very different aggregate effects depending on whether they occur in a sector that has a high multiplier or a low multiplier. Clearly, if low productivity happens in a sector with a high multiplier, that will be much worse for aggregate performance of a country than when it happens in a low multiplier sector. So the question we're dealing with in this paper is how differences in input-output structure across countries, can help us to understand explaining aggregate cross-country income differences. And in order to do that, basically, we use data on input-output tables for many countries, together with data on sectoral differences in total factor productivity and tax rates on gross output. And then we use network theory in order to get a simple mapping between the distribution of these I/O multipliers, which kind of summarize the structure of the input-output network, the sectoral productivities, and the tax rate, and how these map into income per capita. And we can actually get a closed-form solution for this mapping, and we will show that it, as I said, depends basically on the distribution of these three things: I/O multipliers, productivities, and tax rates. So if we know what these distributions look like in each country, we can estimate basically their shape for each country and plug them into the model and then simulate the model and see what it tells us about predicted cross-country income differences. So we can evaluate whether that model makes sense. Now, once we see that such a model indeed has a significant explanatory power for cross-country income differences, we can do counterfactual and ask what would happen if the input-output structure of poor countries looked different. So what would happen if it were as dense as the one of the US? So that brings me to our first findings, namely the input-output structure between rich and poor countries is similar to some extent, but there are also important differences. What is similar is that basically in both poor and rich countries, there are a few sectors which will have very high multipliers or relatively high multipliers, while the vast majority of sectors has relatively low multipliers. So it kind of looks like a typical power law distribution that we're used to. But the difference is that in poor countries, there's a small set of sectors, 4 or 5 maybe, that have high multipliers and provide inputs to the rest of the economy. Whereas in rich countries, the I/O structure is much denser, and most sectors supply basically to a significant number of other sectors. So to give you an example, here we have the I/O tables for Uganda, a small and poor developing country, and the United States. So here we have a 39-sector aggregation. In the rows, basically, in the columns we have the output sectors, and in the rows the input sectors. So if you see a full row, then basically it means that this row sector is supplying basically to all the other columns in the economy. So it's basically going to be a sector that is used by all the other sectors as an input. And if you compare Uganda and the US, you see basically you have more of these dots, which imply that there is significant interaction between the two sectors. So the network is denser. Here we have only 4 to 5 sectors which really are important for the rest of the economy, and that is different in the US. So if you want to see the distribution of these multipliers for these two sectors, in Uganda you see basically most sectors have pretty low multipliers, which means basically they don't have much of an aggregate effect, and there are basically only 4 to 5 sectors, which are agriculture, electricity, trade, and transport. Trade meaning here basically wholesale and retail trade, that have significant multipliers. So whatever we do to these sectors will have a large aggregate impact, while the rest of the economy won't matter so much for aggregate outcomes. And that differs from the US, where the average sector has a higher multiplier, which reflects that the average sector is more connected. And moreover, the top sectors are business services, trade, financial services, things like that. So these are the sectors with the high multipliers are different in poor and rich countries, but in fact they tend to be non-tradable service sectors that cannot easily be substituted with imports. Yeah.
So you are previewing that you are going to do an exercise to see what would happen to developing countries when they have the input-output multipliers of the U.S., but U.S. is a very surface-oriented economy, right? And I'm guessing that services have higher multipliers on average than manufacturing.
It's not true on average. So basically, if you look at things from the very aggregate perspective, services and manufacturing have pretty much the same average multipliers, but they are heterogeneous in terms of some services have low multipliers, there are other services which have pretty high multipliers.
One question?
Sorry, another question. So are you talking about the density of the network or the asymmetry of the inputs shares? Because we know from Asimoglu's framework that it's not about the density of the network, it's about how asymmetric input shares are, how important these multipliers in the end are.
Well, it's going to be a bit of both. What really matters is the asymmetry, as you say. And here we basically have a plot of the distribution of these multipliers depending on the per capita income level. So, for example, countries at the 90th percentile of per capita income, that's the red dashed line, they have a lot of mass here in the middle of the distribution, meaning basically that the average sector is intermediately connected, while very poor countries, so bottom 10% of income per capita, they have most mass here on the left, meaning that the sectors are not connected at all, and that there are just a few sectors over here which are really high multiplier sectors. Okay. And then we also find that sectoral productivity levels and tax distortions interact with the I/O structure in a different way in poor and rich countries. Actually, it turns out that for those countries where we can measure it, poor countries tend to have relatively high, compared to the average productivity level relative to the US, productivities in those sectors that also have high multipliers. So, for example, China is above average productive in sectors like transport or trade or energy provision compared to its average sector relative to the US. And that means, of course, that this will have a relatively large positive effect on China's aggregate performance. At the same time, developing countries also tend to have higher tax rates in these high multiplier sectors. As you can imagine, that's not a very good idea. I mean, maybe you get higher tax revenue from these sectors, but it's also going to be quite distortionary to tax high multiplier sectors a lot. For rich countries, on the other hand, we don't find these correlations, so they tend to have relatively higher productivities relative to the US and tax rates in those sectors that have lower multipliers. So, for example, here we have India and here we have Germany. Here on the vertical axis we have log TFP relative to the US, and here we have the multiplier on the horizontal axis. And you see basically in India, first of all, there's a lot of, India, of course, is on average much less productive than the US, but there's also quite a lot of dispersion in these relative productivities. And on average, at least, the relative productivity correlates positively with the multiplier. And that's different for Germany, where the size of the multiplier and the relative productivity compared to the US tends to be negatively correlated, and that reflects mostly that services are not extremely efficient in Europe, which tend to be the higher income countries in the sample. On the other hand, tax rates on gross output, they're very dispersed in India. And if anything, basically, they have a slightly positive correlation with the multipliers, while the opposite is true in Germany, basically, where high multiplier sectors tend to be taxed less. So, from that, of course, it will follow that the interaction between productivities and I/O structure will have something to say, basically, about explaining income differences across countries. Namely, the fact, basically, that we have an I/O structure will allow us to significantly better predict relative income difference across countries compared to a model that basically just aggregates the sectoral productivity differences, but disregards any input-output linkages between sectors. And on top of that, if we do counterfactuals, if poor countries were forced basically to use the quite dense network of the US, they would be significantly poorer, up to 80% for very poor countries. The reason is basically that the US network is relatively dense, so that means the average sector in developing countries would become much more connected, and that implies that the negative impact of low productivity in some of these sectors, or in many of these sectors, the average sector would have a much bigger aggregate effect. And if we took away this positive correlation between the relative productivity levels and multipliers, so the fact that poor countries tend to do above average in the high multiplier sectors, they would also be significantly poorer, up to 50%. So if you want to take away some message for development policy, it's basically that in poor countries, targeting a few crucial sectors, which are basically the infrastructure sectors, is going to have a relatively large aggregate impact. While that is, of course, no longer true for industrialized countries.
Yeah, sort of a conceptual question. Would this explain the steady-state cross-sectional variation in productivity, or more productivity processes over time, or income volatility?
Well, what we're interested in this paper is to explain steady state, so basically cross-sectional income differences at one point in time, rather than volatility. There are other papers who have looked basically at volatility, maybe not in the cross-country context, but there are several papers by Acemoglu and co-authors and other people who have looked at basically how sectoral shocks propagate, depending basically on the network structure of the economy. But this is not what we're interested in here. So we relate more on the development to the development accounting literature, which tries to explain cross-country income differences at one point in time. And we also relate to the literature on the role of the I/O structure for development, which starts probably with Hirschman in the 1950s, and more recent contributions are by Ciccone and Jones. Now, they make these arguments in a purely theoretical context, and they emphasize that input-output change basically can magnify sectoral productivity differences, because basically as these changes become very long, productivity differences can be magnified. Actually, we don't find little empirical evidence for that particular channel. If anything, basically, difference in input-output structure tend to mitigate basically sectoral productivity differences, because basically the low productivity sectors tend to be not very connected in poor countries. Related is also the literature on dual economies, which emphasizes basically that sectoral productivity differences, in particular in agriculture, tend to be quite a bit larger than aggregate productivity differences. But that literature abstracts basically from the linkages between sectors. There's also one empirical paper by Bartelman-Gornichenko, which also looks basically at the effect of I/O structure on income differences, but they do this mostly in a reduced form context. And that, of course, means that it's harder for them to do counterfactual analysis. So let me go through to the theoretical model. We basically have a very standard neoclassical economy with perfect competition. We have n sectors. In each sector, we have a Cobb-Douglas technology. So gross output of sector I uses capital and labor, and a set of intermediate inputs produced by other sectors, D1I to DNI. So that's basically input produced by sector 1 and used by sector I. And these have weights gamma ji, which are basically the input-output shares. You can read off from the input-output tables. Gamma I is basically the total use of intermediates in gross output. So it's the total intermediate share. We will assume basically that all sectors have the same intermediate share, which is not exactly true empirically, but at least we don't find systematic differences in this in terms of how much sectors use of intermediates. There's much more heterogeneity in terms of to how many sectors a given sector delivers. The matrix gamma is basically the collection of these input-output coefficients. That's the I/O matrix. And gross output can be used either for intermediate use or as a final use Y. And then basically we would just aggregate in a Cobb-Douglas fashion the value added or final use of the intermediates into GDP. So from there we can define a competitive equilibrium with taxes, where basically the small yi solves the profit maximization problem of the final goods representative firm. The intermediate sectors basically face sector-specific tax rates tau I, which basically reduce the revenue of the sector. And firms in intermediate sectors have to choose basically how many inputs they use and how much capital and labor they use. The budget constraint just says that aggregate expenditure is going to be equal aggregate factory income plus incomes from taxes, and all the markets are going to clear.
Why do you want to have taxes? I mean, I guess if you were to do counterfactual with respect to, if you were to if you want to do, I remove the distortion, but your counterfactual are going to be very different. So what's your purpose of actually introducing taxes?
We also do some counterfactual with respect to these taxes.
So and you interpret them as being exogenous, like this distortion, and how do you make sense of this?
Okay, we can partially measure them in terms of taxes on gross output. So we have data on the actual net tax rates that are not deductible. So basically taxes minus subsidies. You could more generally think of them as being distortions that are unmeasured, which is sometimes done in the literature. But it is actually very difficult to back out these distortions if you don't make very stringent assumptions on technologies. So, for example, you can assume that these production functions are the same across countries, and the only difference in these gammas is driven by the distortions. But that would probably not be a very good assumption to make. So partially, these unmeasured distortions will show up basically as lower total factor productivity in the sector. Now, what is convenient about this Cobb-Douglas model is that it can actually be solved in closed form. Yes?
Would you make the same answer if you had tau I on gross output and on value added? Or does that matter?
Whether you have tau I on gross output or in value added makes a large difference, because if you put the taus on the gross output, then you will have magnification effects. While if you use them on, because basically the gross output may be used as an input by another sector, and then you have multiplier effects. If you tax only value added, which is actually what the taxation literature prescribes, that you should never tax intermediates, then you won't have these amplification
So the reason I ask is because in India there was no value-added tax until very recently, so that picture is a little bit kind of misleading if you're comparing the US taxes.
No, but these are not value-added taxes. These are taxes on gross output. So some sectors may face some other taxes which cannot be deducted, so there may be subsidies to sectors. So therefore, it's not about value-added taxes. Okay, so conveniently the model can be explicitly solved for income per capita. It's just a terrible mess because basically this expression for aggregate income depends on all the input-output coefficients and all the productivities and all the tax rates. But what we can do is actually to assume that the input-output multipliers, productivities, and tax rates are random variables, and then you can solve for expected aggregate income in logarithms. It's going to be linear. Like a Cobb-Douglas production function, it's going to have this alpha log k, so it's going to be linear in capital per capita. And the first term here is basically summarizing how aggregate income depends on the distribution of multipliers, the distribution of productivity is lambda, and the distribution of tax rates. So first of all, you see basically that income is increasing in the average multiplier, and that multiplies the average productivity. So basically, if you have higher multipliers and higher productivities, you're going to have, on average, you're going to have higher income. Second, it's going to depend positively on the covariance between multipliers and relative productivities. So if you have higher productivity in high multiplier sectors, that's going to have a particularly positive effect. And the opposite is true if you have low productivity in high multiplier sectors. And income is going to depend negatively on the product of the expectations of multipliers and tax rates. So if you have higher tax rates, then high multipliers are have a negative impact. And it's also going to depend negatively on the covariance between multipliers and tax rates. So if you put high tax rates in sectors with high multipliers, that's going to have a particularly negative effect on your aggregate output. How do we interpret the vector of multipliers? Remember, this is the inverse of the identity minus the input-output matrix, so that's the Leontief inverse. What does an element of the Leontief inverse tell us? It tells us basically if we increase productivity in sector I, how does this affect value added of sector J? And we multiply this with a vector of ones, which tells us basically how is aggregate value added going to change the output of all the sectors. So basically multiplying with a column vector of ones means that we add up the sectoral effects, and the weights are basically the value added weights in GDP, which in this case are 1 over n because the sectors are symmetric. So basically the input-output multiplier will tell us how much a change in productivity in sector I is going to affect aggregate value added. Okay, so given our statistical approach, we can actually look at what these distributions of multipliers, tax rates, and productivities look like. If you look at the joint distribution, it actually looks close to a log normal distribution. And we can allow the parameters, so basically the means and the variance covariance matrix, to vary with GDP per capita, so we can basically estimate different parameter values for each country. And then we can just, imposing the log normal distribution and using our previous formula, get this expression, right? So basically, very similarly as before, the expected income is going to be increasing in the average multiplier, in the average productivity. It's going to be increasing in the variance of multipliers and productivities, and it's going to be increasing in the covariance between multipliers and productivities. And it's going to be decreasing basically in the average tax rates, in the variance of the tax rates, and in the covariance of tax rates with multipliers. So if we have estimates basically for these parameter values, then we can simulate basically what predicted income is going to be for each country, right? So what we're going to do is basically we're going to estimate the parameters of the distribution, of this joint distribution, allowing them to vary with income per capita. Then we use the formula from the previous slide, basically, to simulate expected aggregate income. And then we can see basically how well the model does in terms of predicting aggregate income difference across countries. Once we see that it performs relatively well, we can conduct counterfactual experiments. Okay, so let me briefly explain which data sets we're going to use for our empirical exercise. So first of all, we're going to use the World Input-Output Database, which has already been mentioned. We're going to use only the domestic part of that, so basically input-output tables for each country. So we have around 35 sectors. What is convenient about this World Input-Output Database that the authors have also collected purchasing power parity deflators at the sector level for gross output. So you can actually, and these are going to be the deflators that will enter in the future versions of the 10 world tables. So these deflators can be used basically to construct PPP-based total factor productivity at the sector level for these 39 countries. Assuming basically these Cobb-Douglas technologies for each country, where we allow the production function to have different weights for inputs in each country and sector. So we do not force basically the production technologies to look the same across countries, which would probably not be a very good assumption to make. The second data set we're going to use is the data from the Global Trade Analysis Project, which has data for around 70 countries for basically the same year with a similar aggregation. And we use this data set to get more information of input-output tables of poor economies. And finally, we're going to use the 10 world tables just in order to predict income out of sample. Yes?
In some sense, the input-output multiplier should be global, right? So you have a country that is very export-oriented and is sort of leaking all this multiplier to others.
That is true. I mean, basically, in the baseline version, we restrict this to a closed economy, which may not be ideal given the audience in particular. But in a robustness checks, we allow for intermediate inputs which are imported. And we show that it does not make too much of a difference. And the main reason is that most of these high multiplier sectors are non-traded services. And it's basically impossible to substitute them away with imports. So when we do this structural estimation with maximum likelihood, what we find is that the distribution of input-output multipliers has more variance and more mass in the right tail in the poor countries. So I will show you in a picture in a moment. And not surprisingly, the distribution of productivities has a much lower average and more dispersion in poor countries. While the distribution of taxes also has a lower mean and more variance, so there's more dispersion in tax rates. But what is interesting, as I already mentioned, multipliers and productivities correlate positively in poor countries, while they correlate negatively in rich ones. And multipliers and tax rates also correlate positively in poor countries, while they correlate negatively in rich ones. So again, basically this is kind of the estimated distribution of multipliers by percentile of income, which I've already shown to you. And here we have the estimated correlation between multipliers and productivity depending on the level of income. So you see for poor countries, India, Indonesia, China, Brazil, this correlation tends to be positive. For rich countries, it tends to be negative. And the same is true for the correlation between tax rates and multipliers. It's positive in in poor and negative in rich countries.
So if there are various degrees of vertical integration across countries, would that affect the computation of the multiplier or not really?
Well, firm boundaries may affect the input-output linkages to the extent, basically, that that connections are within a single establishment, right? If you have integration within a single establishment, then it's not measured, basically, in the input-output tables, which in principle are not basically depending on whether a flow happens within or outside the firm boundaries. But if it happens within a single establishment, then it's not going to be measured in the I/O tables. So to the extent that there's more vertical integration in poor countries within the single establishment, that may have an effect on input-output linkages. Yes?
I'm curious, if you looked at the correlation between the multiplier and human capital, what do you think you would see?
You mean human capital at the sector level?
Yes.
It's a good question. I'm
a little bit worried it could be an omitted variable in the sense that in growth accounting, I mean, recent stuff that I've seen, Ben Jones would presumably say that human capital is hugely important. It's not here, and I keep thinking, is there some way that this I/O multiplier could be picking up something about the sector that's really human capital?
So what we do in an extension is to allow separately for skilled and unskilled labor, and that doesn't make too much of a difference for the outcome. So we do have information separately, basically, on skilled and unskilled labor inputs. And when we take that into account, it doesn't make much of a difference.
How do you think about the relationship between productivity and the multiplier? So could that be endogenous in any way? I kind of start asking myself these questions, right? And is it anything to do with misallocation? Isn't the actual observed distribution of productivity across sectors a reflection of which sector uses which inputs? But then I get confused because, you know, if there is misallocation, we should see it in poorer countries, and yet the correlation there is positive.
Right. That's a very good question, actually. So as long as everything is Cobb-Douglas, all the input-output shares are exogenous. If I go away from Cobb-Douglas and say the elasticity of substitution, basically, between inputs is not equal to 1, then basically the input shares depend on the productivity. If the elasticity of substitution, for example, is larger than 1, you will spend more on sectors that are more productive because they will have lower prices. But that should actually lead to a positive correlation between multipliers and productivity, right? But that positive correlation should be there for all countries, provided that the elasticity of substitution is the same, okay? So it's kind of hard to reconcile with this picture where this correlation is not the same for all countries. Now, of course, if the elasticities on top of that were different for different countries, the elasticities of substitution, it would be impossible to identify anything, right? And these elasticities of substitution are also impossible to identify from time series data because presumably these short-run elasticities of substitution, which you identify, for example, are very, very different from the long-run cross-section elasticities of substitution. So it is very hard to identify what these elasticities are if they are not equal to 1. Okay. So taking into account that this is the model has some limitations, this Cobb-Douglas model, we can evaluate the model fit in any case. So in order to do that, we're just going to regress here the GDP per capita relative to the US predicted by the model against the actual one. If it has perfect fit, everything should be on the 45-degree line. And we're going to compare that model with two simpler models. The naive model, which is basically the one that ignores any kind of productivity difference. Well, we know that that doesn't fit very well. And a multi-sector model that doesn't have input-output linkages between sectors. So basically where TFP the aggregate TFP is just a weighted average of the sectoral TFP. So basically we take the same estimates that we get for the distribution of productivities that we use for the model with input-output structure, but we just ignore the interaction between the I/O structure and productivities. And here's basically what you get for the world input-output database sample. So that's the sample on which the model has been estimated. This is on the vertical axis, you have the predicted income per capita. On the horizontal, the actual income. The blue circles are basically the model predicted relative incomes with the model with input-output structure. And the green triangles are the relative predicted income levels when you ignore input-output structure, but just take aggregate basically the estimated productivity levels. And you see basically that the model with the I/O structure fits really very well, while the model that ignores the input-output structure tends to make many countries poorer than they actually are. And the reason is that sectoral productivity differences are significant, even larger than aggregate ones, but these large sectoral productivity differences are to some extent mitigated by the I/O structure, because those sectors that are really unproductive in countries tend to have low multipliers in the poorer countries, so they don't have too much of an aggregate impact. And we can repeat the exercise for the GTAP sample, where we have around 70 countries, or the full Pan World tables, where we have around 140 countries. And you see that, again, the model with input-output structure, which is here in green, is pretty close to the 45-degree line. Just for the very poor countries, we tend to over-predict income. So that's basically, in particular here, all out of sample. So we tend to over-predict relative income levels for very poor developing countries. So to summarize, basically our model with input-output structure has significantly more explanatory power in terms of predicting cross-country income differences than a model that ignores those cross-country, these input-output linkages. So once we're sure that the model makes sense in terms of predicting income difference across countries, we can do some counterfactuals. So suppose basically we impose the dense input-output network of the US on other countries, how would their income be affected? Or suppose we take away the positive correlation between productivity and multipliers that we actually observe in poor countries. How would their income levels be affected? Or suppose basically we gave all countries the US distribution of taxes instead of the actual tax distribution. Would that change their income? So if we give all countries the very dense US input-output structure, you see basically that predicted income in all countries would go down by up to 80% for the very poor countries. And the reason is basically that these countries have very low productivity on average, and it's highly dispersed across sectors. And they also tend to have above average productivity in the high multiplier sectors. So if we impose basically the dense network, which forces each sector to be much more connected to the rest of the sectors, that has a very negative aggregate impact on these economies. Similarly, if we take away the fact that poor countries have a positive correlation between productivity and multipliers, while rich countries tend to have a negative one, then not surprisingly, again, poor countries would suffer a lot, right? So if we took away the fact that transport or energy also are above the average productivity level in these poor countries, they would be significantly worse off. How about changes in tax rates? So if we impose the US structure of taxes, that would not matter much for most countries, but just for the very poor countries, having a lower variance of taxes would be beneficial, up to 4 or 5% of per capita income. How much time? Should I conclude?
We should try to
Okay. So, to conclude, basically, it seems that differences in input-output structure together with sectoral productivity differences do help to explain, to some extent, aggregate income difference across countries. In particular, when you take sectoral measures of productivity differences, you tend to find larger cross-country productivity difference than when you just bag it out from the aggregate. But poor countries do relatively well on the aggregate compared to the low productivity levels that they actually have in some sectors, because those sectors that are really bad in those countries, they are not very connected to the rest of the economy. And therefore, this effect is mitigated. As a consequence or takeaway, it seems kind of that it's becoming rich is even harder than the naive model predicts, in a sense that as countries become richer, it seems that their network structure becomes denser. And while in poor countries, increasing productivity in a few crucial sectors has a large impact, that's no longer the case, basically, for countries that are industrialized or modern service economies, where all sectors have a significant impact, basically, on aggregate performance. That's all I have to say.
I was a bit uncomfortable with your taxes, like being a random variable. You're saying, you're saying optimal taxation would say you wouldn't want to tax. I mean, why would you need them? Okay, for your counterfactual, but I was, if you took out that from your model, which I think you would get still all your main results, no?
Yeah, tax rates are not so important. I mean, actually, in the paper, we also have a section where we do optimal taxation. And if you do that, optimal taxation prescribes that you basically should, in developing countries, increase the average tax rates, but you should shift basically the tax burden from the high to the low multiplier sectors. And that would be the optimal thing to do. Yeah.
Okay, so we move back to firm organization. I thought I made a mistake in the program. I should have put you closer to the macro panel, but we go to Laura. And we go back to micro.